now we are going to deep dive into our topic, generative AI, etc. First use case, drug discovery. And I would like to welcome Kristina and Ouisseme. Yes.
Thank you very much. Hello, everybody. Perfect. So, hello. My name is Ouisseme. This is my colleague Kristina, and we are here today to talk to you about the, I'd say, general impact of AI and LLM on the life science landscape with a little exercise, or I'd say, example on the drug discovery, and basically give you what we will call a consultant's perspective. So what does that mean for the field, but also what does that mean for us? Perfect. So the Vega's kind of motto is building the bridge, between IT and business. And basically the idea is to be able to know how business evolves, but also be able to have technological knowledge enough to help navigate all of this for our clients, but also for ourselves. So yeah, that's the agenda for those next 10 minutes. So present briefly us, then give you kind of a customer request perspective on this and really the consulting side. Give you some example of framework of AI implementation, so a bit of a technical dive, and then kind of deep dive into what does that mean throughout different examples, and then we'll kind of close it up with a link between clinical and preclinical. Okay, quickly on the company. So we are a relatively small, 30-year-old company. So Vega Informatics is a Basel-based company who evolved in the past 30 years from pure IT to what it is now. And as you could guess with what's coming, we might have to evolve, and this is why I think it's interesting to see the impact of those new tools in the landscape in general. If you want more detail, we can go into more details. Yeah?
It's on.
Yeah. Thank you. So basically, as Ouisseme already said, so Vega is 30 years already in the field with life sciences, but what we have seen is a little bit of a shift, of course, with all of the topics that are outside. So from classical lab automation support to LIMS and LLM implementation, lab tool evaluation, and computerized system validations, we have, so these requests have not gotten necessarily disappeared, but we also have to deal now with system connectivity, the cloud architecture, of course, data infrastructure and management, global business processes and policies. And when I say that, it's a little bit different of a perspective when you make an AI tool or LLM for one side or one small company versus when you really have to operate on the regulatory end for multiple sides of a global company to make that all work properly. And next to CSV, what we also have currently right now are, of course, medical devices. And in all of that, across AI and LLM tools are applied and requested by our customers. When we think about that, what is the framework, how you should start, or at least as a consultant that needs to take care of everything end to end, is a sort of a framework. You first need to understand what is actually the request of the business process. What does the customer in pharma wants to adjust? If it's in drug discovery, probably it has something to do with leveraging all of your knowledge that you have before the data, or if you are in drug development, really enhancing what is in the preclinical that you can use in the clinical space. And we also try to assess through that, okay, what is needed and what is the digital maturity of the company and what are they capable of handling. Just implementing as crazy, like a lot of AI, but you cannot handle it, is also very dangerous. And then the possibilities across all of that landscape, we are trying to either select the right tools or develop customized scripts and tools for our customers. And we are trying also to make a risk-based approach. What does that mean? If you are using LLM, for example, like Copilot is based on LLM to generate some code, it is less risky because you always will test out your code. if you are using it in order to generate a summary of all of your text-based knowledge that you had before from preclinical, well, you would have to read all of the text in order to make sure that the summary is correct. So it is more risky to actually do that just blindly. And then, of course, afterwards, what people also tend to forget, it has to be maintained and to be governed. So if you ever have to go back to older version of you because you're a pharma company, you need to be able to do that. And we are trying to give a perspective here, how does that look like when we think in blocks. So of course you have your users, but then the ground is the governance and the documentation. You need the operating systems and the computational resources that we can also take care of. As I said, we are in the cloud architectures. And then building the platform, so if you have multiple tools within your pharma company, we help our customers also building that all. And the DevOps, the MLOps, storage, also your databases should be versioned properly, so you can always go back, and then the application itself that we see and often just present is on the top, so everything else around it needs also to be foundational grounded. When we think of generative AI, what does that really mean? So you can have, for example, also only LLM, but if you also have your synthetic data inside, you should really think of, okay, first you generate something, you ingest, of course, new data into your whole pipeline across the company. You have the storage, the transformation, and then the serving, again, is just the latest stage that you actually do. And with that, we were also thinking what can be done beyond just AI and LLM.
Yeah,
That's
and
for Ouisseme.
I guess the big topic right now is no one's using one thing, right? You have Gen AI or LLM, and then you mix it with whatever you kind of feel like it, but also whatever can interface and enhance. A good example, I think, is knowledge graph, because I think one of the advantages of knowledge graph is it's kind of field agnostic. As long as you can parameters with the right parameters and develop the connection you want to develop, those tools, a few exist now. I think one that kind of everyone kind of might know is Neo4j, is a good way to build something that also can be visually speaking, easier to maybe also translate to others, but can be enhanced. Okay. And to just put it back within the drug discovery context, the idea of a knowledge graph is kind of a basic, right? You have the important points, and then you think of how they would connect. It's just kind of two examples of knowledge graph within drug discovery, and as you can see, it's also similar to how our brain works, right? You see something like, okay, how does it link, and how does that correlate, and what could be the iteration, and what could be the loop. And all of this can then be enhanced together, be mixed in a big pot, and make your tool the way you want it. But also that means that we end up with new needs in terms of our clients, which is the importance of, again, understanding business, understanding the targets and the needs and the goals, but also how those different and various tools can be visually important, but also beyond the drug discovery part. What does it mean for documentation, governance, policies, and kind of beyond? Because obviously, especially in the life science field, similar to all of the field, but I guess here in Basel it's also a big life science hub. We have the FDA requirements and the Swiss Medic and all of those that needs to be imputed to those reflections around AI. And with that, I think we're good on time. Thank you very much for listening. Please get in touch with us after this, but also through our various means of communication. Thank you, guys.